Welcome back to Mechanical Engineering Design. This is a briquette making machine. Welcome to my live. Today we are going to look at simulation of a briquette making machine. If you are new to my channel, please ensure you share my video because it means a lot to me. Now let's get started. This is a briquette making machine and it's a continuation of my previous video where I showed the mechanism and also the design, but I'll quickly take you through the design. So, and as you can see, I've made a simulation of how all the process will go through. So first, let me just take you through the mechanism. Now, the purple part is the frame. It's the main frame that holds all the parts together. And below here is the motor. Which has a pulley at the end. This pulley has got a belt drive. It's a belt drive which connects to another pulley at the top. Now, this pulley drives this shaft, the yellow one, and this shaft is connected to the auger inside here, or the extruding screw. Now, if you look at the extruding screw, it has been made in such a way that it reduces towards the end. As you can see, it's tapered towards the end. So this ensures that when material is put on the hopper, it goes inside, and here the screw will be driving forward. And towards the end, the reduction in cross-sectional area will ensure that the material is compacted or squeezed. Now, the squeezing will apply pressure on the material, and the material will be extruded here, which will have a very high density. It will be extruded at a high density. Now, upon dropping here, there is a cutting mechanism here, or a slicing mechanism. This slicing mechanism will ensure that equal portions of material comes out. So after some rotation, it will be slicing. So you'll be getting equal amounts of briquette at any point. Now, the briquette will drop into this receiving tray. Now, when it's here, the operator will just be spreading them on the tray. And below here, we have a heater. If you can observe, this one is a heater. So this heater will be heating the tray to raise the temperature of the tray. And in this case, you can extend the size of the tray as much as you can, so that it can accommodate the size of the material you are extruding. So this tray can be as large as you can. Now, back here, here are two bearings to hold the extruding screw. And here we have two gears. There is one smaller gear and secondly, it's coupled with another large gear. Now this will ensure that the speed of the auger is slightly lower than the speed of this gear. So by reducing the speed, it will ensure that the speed of the slicing mechanism is a bit slower, so that the right amount of briquette can be extruded at the end. It will also ensure that you are using the same motor in all the mechanisms. One motor will be able to run the extrusion, and at the same time, the motion will be transferred to the cutting mechanism. So, and finally, you'll have your mechanism. So here is a simple motion study which shows all the process, and as you can see, the material will be put here downwards, and the auger will always be rotating, driving material forward, as you can see. So once the material reaches this point, the right amount will come and sliced and start continuously. You see? And this is how this mechanism will go through. You'll be able to extrude the material and at the same time slice the right amount of the material. So this mechanism is efficient, it's time saving, and ensures that you get the right amount or equal portions of briquette extruded. And also, by adding heating mechanism at the end, you are also able to get a dry briquette, or the briquette will be able to get dried at a short period of time. So if you don't understand what a briquette is an alternative of charcoal. Okay, so you are using waste matter or things like sugarcane leaves. You can use coconut husks. So the first thing you do, you carbonize them. And what I mean by carbonizing is you put them in fire that has restricted amount of oxygen. So this will ensure that you heat them, but you don't heat them to ash. You have to maintain some charcoal in it. Now, after that, you have to mix them with binder. And the binder in this case can be molasses. So mix them with binder and drop them on the hopper here. So just drop them inside and add the right amount of binder, and then the machine will run, do the crushing, mixing, and extrusion at the same time. So you are able to get an alternative to charcoal. Okay. So you're using waste to extract charcoal, of which you are conserving environment, will not be cutting trees. Therefore, you are lowering cost. So if you have any question, drop it in the comment section and I'll be able to answer you right away. Anyone with a question? So this project can be commercialized. It's a very practical project. So if you are looking into an alternative to charcoal, this is the right project. You can invest. And it's not expensive, as you can see. For the body, you can use mild steel to construct. And on the pan, you can use stainless steel to increase that lifespan, because it will always be subjected to heat. The bearing have to be maintained, you have to do oiling, the bearings and gears. You have to be there regularly to check. On the part of safety, the bearings have to be enclosed so that the operator will not accidentally put their hands on the bearings. So I hope you understand the mechanism over here. It's actually self-explanatory. So you see the larger pulley has got a pin here attached. And then this part has two holes. One hole is here and another one at the end. It's actually not a hole but a pin. There's a pin welded on the other side. This one. And this pin will go into a slot on this part. And on the frame we also have another pin to hold this point, which will act as a pivot. And that's how it will operate. As you can see, it's just like a crankshaft. And of course the blade is sharp. It's sharpened. Let's look at it from the top. You see how it drives the material forward. Very functional. Any question for me? I have one question here. What is the energy density comparison between briquette and charcoal? Now in the case of briquettes, because we are adding binder and also compressing by increasing the density of the matter, the energy density of briquette is a bit higher than charcoal. Yeah, because we are increasing the quantity of matter per unit volume. So I hope you understand. Any other question? So if you compare the energy obtained from briquettes or burning briquettes, you'll have a lot of heat or energy than the normal charcoal, because normal charcoal will depend on the type of tree you are operating on. But for briquettes, you are compressing them, so you are increasing the quantity of matter per unit volume. So if you have seen briquette anywhere and ask around, you will notice that they have a lot of energy. Any other question?